to receive this award from the Marconi Society. It's a privilege to organize this symposium. It's also somewhat difficult at times, particularly when it coincides with the first day of the main ICT conference of the European Commission, and yet another one on, I think, spectrum and other things in the UK. So, yes, I have got very distinguished groups of speakers, but on the other hand, there are one or two who could not come. One, for instance, happened to have an appointment with the Prime Minister of Lisbon, and as he was senior in the EC, he felt that had to have priority. Anyway, next please. Can you move it? It's there. My daughter Claire is going to be invaluable to make sure that the slides stay in synchronism with my talk. Anyway, this is an introduction to the symposium. So it's not about anything specific, no specific theme, but it sets the theme for the whole one. Next, please. Well, why is there any fuss about the Internet of Things? It's the Internet. It says it's the Internet. It must be the Internet. There's some minor extrapolations. In 1969 to about 1980, one had an ARPANET that was capable of going to 64 sites with some 250 computers. There was a little minor extrapolation from, started off by Bob Kahn, Vint Cerf, which went up to something like 16 billion sites and as a million sites and 4 billion computers possible. Well, then somewhere around its midlife, 2000, between 1990 and 2000, one developed something else. This was somewhat bigger. It was able to have something like 10 to the 20th. You can work out how many millions and billions that is. Sites, an equal number of endpoints. There's some argument as to what an endpoint is in this context. So surely, since Bob Kahn and Vint Cerf are still around, no problem. Well, there is some other differences. With the Internet of Things, it's not only the number, and you are talking about very, very large numbers, but it's also the fact that they actually use devices and not just all devices which we're using, not just computing devices as we knew it before, like telephones, laptops, iPads, computers. Next, please. The Internet was mainly accessed by people. It was mainly so that people could interact with each other and with computers. So to some extent, the number of such devices was actually dictated by the number of people in the world. Whether you had a 20% penetration or a 90% penetration, and whether they had one computer each or 5 computers each, it was still sort of the order of 10 or tens of billions at most. They also had a fairly rapid turnaround. Very, very few of the computing devices last for longer than 3, 4, 5 years. When you get to the Internet of Things, they're very different. The whole gamut of short to long is different. The numbers are completely different. If you take your average car, you already have, I think, 100 computing devices in it. The number of devices which you might want to have interconnected in some sense or other is hundreds of billions, trillions. And in a fairly short period of time, one sees estimates like 100 billion by 2025. These are very rapid growths. When you add that to the fact that it's very, very hard to get some of the applications areas there to change their mind, even to know what might be wanted or needed, you'll see that you're going to have a real challenge. And there is another huge difference between the Internet and the Internet of Things. Bob and Vint had their first paper on the protocol for the Internet in 1975. It wasn't taken really seriously by industry even after it started being deployed in 1982 until somewhere around 1985, 1988. That means they had 10 years of luxury of actually being able to develop the things properly. With the Internet of Things, it is so obvious that of its commercial value that there is huge pressure to have things happen very, very fast, possibly long before they are ready for the sort of deployments one is talking of doing. And the result of that is that one may be making investments which are huge but wrong. And that is something we should certainly worry about. Next, you've got that one already. It has an impact in health, everything from how you run things in hospitals to implanted devices in humans which you can be monitoring. It has it in transport, again, any number of variables. In buildings, and remember, as far as buildings are concerned, they might be changing only in 20 to 50 years. In cars, they can change fairly fast, like 10 years, 20 years, but it may take at least that period of time to get them to adopt any particular procedures. In energy, in agriculture, all of these are often slow-moving in their investment cycles. Next, please. So what really important for this particular symposium is what infrastructure might you need for this? And one important part is digital objects and applications and how they're all designed. You can usually, in every deployment you make, there's some sort of digital model. It might be an architectural plan of a building, and that in fact will have several sets of models. I don't have time to go through it all. You'd have a model of a car which includes what devices are digital devices inside the car. From those, you'll come to a set of things which must be addressed in that entity, and also, which is very different in the Internet, how it's addressed. It may have certain procedures to addressing, and these may not even be unique. There may be several, depending on who's doing it and how. So in fact, you start having a combination of deployments and applications. And the devices themselves look different depending on what application is being done. Let me give a simple example. You have an air conditioning in a house, in let's say a smart office. To some extent, you as the occupant can adjust the temperature, but not much else. The operator of the building might be able to do something rather more sophisticated. They might be able to do something rather to improve energy consumption, make sure that when people aren't there, it's not heated, etc. The person who is actually repairing or servicing that air conditioning from far away may want to get right inside it and doing things which they wouldn't allow the building's operator to do. So the same device can have quite different ways of accessing it and identities. And that identity is a combination of the device and the application. This has some quite far-reaching implications. You can't just look at the application itself. You can first of all do something about, from the model, construct the application. Then, from the having a fixed application, you may need to do something with the application itself. You can describe the models in cyberspace, in space, not in physically. And if you think that's not very real and physical, you can then put the connection between the conceptual design and the cyberspace versions to the physical by having some form of describing it with attributes, one of attribute being the physical network address of the device. And that would combine them completely. I say a little bit more about that later, but in fact, Bob Kahn, I think, will be saying very much more when he gives a talk on the whole subject of identifiers and data management. This is a huge subject, and there are some things we can treat, and there are some things we can't treat in a one-day symposium. We're going to say something about we're going to try to concentrate on the fundamentals and say something about the identifiers and the data management, on the networks which one would use or might use or will use, on big data, because one result of controlling things, of monitoring things, is to produce large, or can be to produce large amounts of data. Then there's the whole question of security and privacy. That is a major problem. We already have a problem with that in the internet as it is now. We know how often we have hacking. We know how many ways there are of both breaking in, measures, countermeasures, and then we have the whole question of privacy. It's very difficult to decide who is allowed to see what and how can you control it, and we have a whole session discussing some of that. And then it wouldn't really be complete to have a symposium like this without having something about the deployments themselves. And we'll say a little bit about that. But then there are very important things which we can't consider. We can't really consider any of the protocols which are used either for the applications or for the networks. We aren't really going to be talking very much, if at all, about the sort of platforms one has, and even the thinking behind those platforms. I'll give an example of where there are 3 different industrial consortia with different concepts. Then the whole question of governance and regulation of the Internet of Things, we're not talking about, although I'll say just a little. Then there's everything to do with the economics and the pricing. Absolutely vital to see whether it's worth and what it's worth introducing, but it's much too complex to talk about here. And then what are the roadmaps to transition? And that last one is a particularly difficult one on the grounds that so often people have bright ideas about what they would like to do with the Internet of Things. Sometimes it includes more or less throwing away everything we've done up to now and then doing something completely new and different. Whether or not that is even a possible roadmap is, of course, very arguable. Well, let's look about the nature of applications. Almost all the applications which people have actually deployed properly have been a single provider, by a single provider, either with just one application or a number of applications which they have defined or have been defined for them. For instance, one of the use cases might be the sort of thing which Uber and others have done about controlling, or at least knowing where cars are when you order a car. But once you have a car which is already broadcasting something about its presence, or be it by GPS or anything else, it could perfectly well broadcast a lot of other things. Some of those are used by the organization which originally is responsible for that car or that fleet of cars. For instance, the parcel delivery service would like to know where it is for parcel deliveries, Uber for, and even the customer in the case of Uber, for where the car is. But once you're doing that, you can also have lots of other things which could be very important. Fuel consumption, obviously, pollution control. It's a nice way of doing pollution, and various other things. Of course, the pollution one immediately brings yet something else which is very topical. You can get measurements. Are they realistic? Or has someone manipulated the program which provides it so that it's not even correct data? So that leads to the whole question of trust in what you're getting, and calibration and testing of these things. Very complex areas. But in any case, you first of all start with having some application models, some models of the application. Then, models of deployment. Then for the applications, now you know what the deployments are, you can start thinking about what you do with them. One thing you might be doing is just taking the deployment as it is now, having a database for that and its attributes, having a new set provided then for it, which puts in new identities for the combination of deployment and attribute. And therefore, you get a much more difficult, more complex digital object with which you can deal. And of course, you may need to have some security associated with that, some metadata about ownership, etc. And you may, for instance, need for that metadata to know who must negotiate with whom about what for that access. Perhaps the best thing to do is to take a diagram of what much of the time one is talking about in this Internet of Things. First of all, there is the general Internet. Then there is something which I call here the service net. The service net is that network which deals with the specific deployment of interest at this particular moment for this purpose. And most of that will these days be IP enabled, Internet Protocol enabled. But some of the devices won't be. In a building's automation system, you'll very often have devices which are not IP enabled themselves, but can be accessed through controllers which are. That I've shown here as a device net. Most of what one deals with in the Internet of Things is that middle one called the service net. Next, please. Well, I think you go to the next one. And I talked about deployments, and then I talked about applications. I talked about deployments as there was a deployment. This may not be the case. You may, for instance, have data models which provide a deployment of all the street lamps. You may have another one which describes things about lights in an arena, sports arena. You may have several different models which describe a different part of a smart city. But you then may have some applications shown here as one, which goes across using bits of all these separate deployments. And that's what you may be wanting to do in an application for the Internet of Things. So the actual network used for that may well be almost a virtual network. It's not a network which any single deployment knew about, but of course they must all be accessed. Next, please. And then next, please, again. So here you have an example where you have these separate deployments, and then you have a number of different applications. And the applications themselves may be over the same deployments, over different deployments, over combinations of deployments, and in fact, rather than that diagram, have the next, please. You really got a whole sea of deployments and a number of different applications. Sometimes you'll have several different applications talking to the same devices, shown by overlapping applications here. In that case, it's particularly convenient if you are defining digital objects as being the combination of devices and applications. They have different identities, and those describe also the different ways of accessing them, the different security concerns, the different privacy concerns, the different ownership, and therefore the different things one can do with them and who one must negotiate with in order to be allowed to do those things. Next, please. Next, please. Well, for this, one way of doing it is to have, with the identity, in the Internet you just talked about named address mapping. Here you need much more complex things with many more types of attributes and possibly security with all of them. We know how to design that sort of system. The domain name service has already done it, and there's a similarity in the design, but many more complications in what you would do and need to do in the Internet of Things. Next, please. I don't think I'll go into this detail. I was suggested that I go rather faster. There are advantages in using IPv6 for some of this. When one was starting talking about IPv6 for this some years ago, the main advantage was supposed to be the fact you had this large address space, whereas in IPv4 you had a much smaller address space and then had private addressing for all the devices. In fact, with IPv6, of course, you have a much bigger address space, but you find it much, much easier to use multiple addresses for the same devices, same endpoints with different applications. And in addition to that, when one developed IPv6 over IPv4, one took the opportunity to do a number of things again, like the way one did group addressing, the way one had scope of where one went to, and these turn out to be extremely appropriate for the Internet of Things. Again, there is no time to go into that in detail. There are, however, a number of challenges to do with where we go in the Internet of Things. One challenge is interoperability. It's all very well to talk about having a broad range of things you can do in different domains, but very often you'd like to go across domains. All of us have a certain amount of smart homes and some of the things you can do in the home, and have things like electric meters, gas meters. Both of those get automated. Both of those can be automated as part of the Internet of Things, to make sure that those automation systems can interoperate in such a way that you can easily have applications going across all these domains can be much more difficult. So that is a major challenge. One system which Bob has got on this subject does go into some of this, because although there are a number of different identifier systems, you can have the actual identifier as one of the attributes of one of the descriptions, and then it goes to the other system itself. Then there's the question of the governance challenge. We've had the initial model of the Internet was wonderfully simple. Everything to do with how you did it was done by the Internet Engineering Task Force, one organization. It had its own way, it had its way of doing things. It was democratic, everybody could join, and one could have regular meetings and discuss and have a uniform way of doing things. Even that became rather more difficult when the commercial pressures became high. Very often, what people were trying to do in the Internet of Things, in the Internet, started being related to their business activities, but it still was possible. The first time you started getting difficulties was when it became very clearly part of communications. So was it the ITU or was it the Internet Engineering Task Force which decided things? Then you had the World Wide Web, and was it the World Wide Web Consortium which chose things? Well, once it was a fairly small number, yes, you have a large number of, well, you have some who have to agree with each other, which wasn't easy, and you have many meetings of the Internet Governance Forum to try to resolve some of these things, and they're not resolved. With the Internet of Things, that's going to be very, very much more difficult. You're going to have a huge amount of government regulations on things, of industry. There's no way it's going to be easy for the power industry, the automobile industry, the home industry, the building industry, the health industry, all to come to some common ways of doing things. That's going to be a major problem. It's problems both from the point of view of governance and others. There's a platform challenge. There are now starting to be a number of industrial consortia trying to agree on how you build platforms for IoT. Although there are quite a number of different ones, they don't necessarily do exactly the same thing. For instance, one of them is only concerned with how you interconnect devices to systems. Another is concerned with how you do it in such a way that you're mainly using the Internet protocols. A third one is only interested in how you go from a cloud, which actually holds the data, to the end systems, the Internet of Things. They also have different domains they're interested in for these. To have those different industrial consortia who are developing products and systems for their way of thinking and trying to harness other people to join them, it's going to be very difficult to actually put any sort of sense between them. I give here some very specific examples. Again, I believe the slides will be available. You can look up the details of those particular platforms. Sometimes there's even an attempt to have a government or European initiative which defines once and for all the platform for these things. Open IoT is one of these, and it does some very good things, but whether it does enough to meet all of the pressures on it is another question. Next, please. Privacy, security are absolutely key to all of this. And that means so many things. Yeah. It's a question of what does your Barbie doll do? Do you have privacy when it's voice activated and is listening to things? Does it do it locally or does it do remotely? And if it does it remotely, what else can it listen into and who can listen to what it's listening into locally? And yet the effects could be absolutely devastating. We saw an example of that with the Iranian nuclear activity, where one was able to completely destroy the way the centrifuges work. Well, that was probably not done over a network, but certainly if it had been networked, I don't know exactly which way it was done, it could be done that way, and that means it could be done for almost all the services we have which run our civilization. A lot will be said about that in the session this afternoon. So let me just say exactly what we're going to be doing in the symposium. First of all, there'll be two talks on important technical aspects. Well, first of all, sorry, there's going to be workshop, a actual panel on what networks to use. And here I hope we will find some differing opinions and some real discussion. Then there'll be two talks, one on identifiers, one on big data. Then there'll be another panel on privacy and security. But first of all, there'll be some position papers in each of those. And then we have three examples of real deployments. I'm going to find this interesting. I'm looking forward to the symposium. You've heard enough of me. Let's go on and start the symposium. Thank you.
Thank you so much, Peter. That's a lot of food for thought there and an introduction to the day. I have just a short time to take a couple of questions, if I have any. Yes, there's one here. I think there should be some microphones. No. Speak very loudly, please, and I'll repeat the question.
I'll do my best. Christian Laranaga. Peter, thank you for a wonderful exposition of the issues around IoT. I have one of the things you were talking about that intrigued me was this idea, really like a main idea where you link IPv6 addresses and link with the main specifics of the device. The industrial network will have one IPv6 device and another user device has another. They each have some way of coding or using, accessing that device. The question I have is, where can we put the user and the device owner? Are they not the same in that context? Where's the control mechanism over the device itself?
Well, whether that's on the device itself or whether it's on the application and the privacy and security put into it, I have said there is an identity of something which is a combination of the deployment and the application. And that has with it metadata, or when you're designing the application, on what can be done about accessing it. In fact, there is, I think, a slide which I think I skipped over. There has been a meeting just a few days ago by those responsible for data protection. And they have even suggested or stated as an agreed principle that data should be, before you do any deployment, you should decide what the data is for and that it should be collected only for that purpose. Now, that goes completely contrary to what I was saying, because that would mean you can't use it for other purposes, or at least it's very difficult. And the idea there would be that when you are doing the actual combination of application and deployment, you also have very careful controls about how and who can access the data and what is the security privacy infrastructure which permits the use of that, and what is the security infrastructure which the application can actually do with respect to the devices themselves. Some of that is absolutely essential in any case, because there is an owner often of deployments, and they themselves will put some constraints, but there will be many more depending on society and agreed, and that's where your problems are going to come. That's why I said it was a challenge. How you actually determine what those controls are. And you have one particular, I think, irreconcilable one. It takes much, much longer to agree how you do things as far as governance and regulation than it does to get round them through our technical means.
I take just one more question, Bob, in front.
Yeah, Peter, in the early days of the internet, there was a lot of discussion about whether we could get a common way of doing interaction versus protocol conversions end by end for every possible protocol. And I think the success of the internet was due to the fact that we had a common way of dealing with things through the TCP/IP protocols. How optimistic are you that we'll find a common way of dealing with all of these interactions in the so-called Internet of Things going forward?
Well, thank you. I'm sure that was a deliberate question. In 77, 78, Vint and I wrote a paper about how you connect networks together. And at that particular time, Vint and I disagreed, and that's why we wrote a paper. I said, there's no way you'll change the world. You have to adapt between one way of doing things and another. Vint, partially because of your influence, partly his own, said absolute nonsense. Everyone will adopt the internet protocols. Well, I don't know whether to be proud or bashful the fact that I was right for the next 15 years. But after that, I lost completely. Vint won. Well, 35 years later, Vint and I went on holiday, and we discussed, wasn't the situation in the Net of Things roughly the same as the networks were in those days? So we wrote another paper on the Internet of Things, an old problem revisited 35 years later. And I'm afraid we've come to the same conclusion. It would be wonderful if you can have a uniform way. I think that the sort of system which you are advocating, and I presume you'll talk a bit about, does a lot about that. It at least allows one to use many, many different systems from one system. To what extent you really get semantic interoperability, every other form of interoperability, complete agreement on even how you set about security and privacy, and whether or not you can use the same procedures for a $5 device and a $500 million device is somewhat doubtful. But using proxies and being able to use proxies reliably on some of these is one way of going through them. And the fact that you can have very reliable and very fast data makes some of these proxying systems at least possible. Whether or not you get complete agreement of completely uniform adoption, unlikely. Certainly, some of these industrial consortia are hoping everybody in everywhere will use their system. But there's some pretty big and powerful players competing with each other to try to get the uniform solution. I'm not optimistic it'll come, certainly not in my lifetime.
Peter, thank you so much. What I think we'll do is continue this discussion under the panel. And of course, I'm sure anybody that wishes to address questions directly to Peter, we can do that under the panel. So I have eaten somewhat into the panel time, so without further ado, I'd like to introduce you to Vint Cerf, who will be the moderator for the panel. Vint is the Vice Chairman of the Marconi Society and Internet Evangelist for Google. So, Vint, over to you.
So good morning, everyone. Peter has done a wonderful job of laying out the massive landscape that the Internet of Things presents us with. And with reference to our debate on the second paper that we've written together, I'm afraid Peter is going to win. I'm hoping that he won't, but I'm afraid that all the evidence suggests otherwise, that there will be great diversity in this space. So what we're going to do, I'm not going to invite all the panelists up here at one time. What I'd like to do is to bring them up one at a time to make a few remarks to give us a sense for their perspective on the basic problem of building infrastructure to support this vast quantity of devices which is threatening to descend upon us. And after we explore this underlying infrastructure, then I'll invite all of them to come up here and have a bit of discussion among themselves, and followed by an opportunity for those of you who are down there in the audience to also raise issues and debate. We have until about 10:45 to do that. So let me just begin by making one or two observations. The first one is that we are already faced with quite a diversity of physical methods for permitting these devices to interact with each other. And we are going to hear from the various panelists different aspects of communication technology that might be used in order to link these devices together. Second, there will be a set of other issues arising that Peter's already hinted at, having to do with access, with control, with the distribution of the data accumulated from these devices. Some of those issues, safety, security, and privacy, will be taken up in other panels later on. So right now, I think our interest is in figuring out what the infrastructure is likely to look like and what the raw ingredients are for supporting this very diverse collection of devices. And so in order to do that, I'm going to invite the first panelist up, Ming-Chi Fan, who's Vice President of Engineering in the Research Systems Department at Qualcomm. And rather than reading his biography, may I suggest you have a copy of it already in your brochures, but I will ask Ming-Chi, please come up and maybe say a sentence or two that you want people to know about you before you give your introductory remarks. Sure. So thank you very much. Okay. Ming-Chi, the floor is yours.
Thank you very much. Well, so good morning. It's really a privilege to be here and to really try to introduce some of the ideas about how we can use the wireless infrastructure and to really connect all the Internet of Things all together. So just a quick self-introduction. My name is Ming-Chi Fan, really appreciate introduction from Vin. And then basically, I'm currently doing research in Qualcomm R&D department, focused on unlicensed band primarily, but also some of my work is looking forward to 5G also. So today, I think it's very interesting that I joined a company in 2002, around this particular time frame. And today we're already talking about 5G. So in the past, about a little bit over 1.5 decades or so, you see things really has evolved. back in the 2000 times, we're talking about, what in the world can you really use 3.1 megabits per second for, for application? But today, as we see that every generation of technology, going from 3G to 4G, now moving forward to 5G, you really see an increase of data rate and bandwidth by an order of magnitude. That's really one of the things. Today we're talking about the hundreds of megabits per second, moving to gigabits per second in terms of data rate. But besides that, another very important thing in the technology evolution from a wireless, from a cellular perspective, is also on some of the things that the infrastructure and architecture has enabled. 3G basically enabled data communication over mobile. 4G basically enabled MIMO, as well as basically the capability to do heterogeneous type of network, meaning you will have small cells, macro cells, and Wi-Fi all working together. So now we're trying to anticipate what would 5G really enable. And the way that we are looking at is, by looking at what 5G is going to enable, one of the key aspects we anticipate, just like Peter has basically outlined a big scope for us, is really anticipate a connection of Internet of everything coming to space. And that's really the platform that's going to happen from a wireless aspects. Yes, 3G and 4G has IoE, has IoT, but 5G will do this in a very different way. And here's a how, okay? So without going into a lot of the details. When we talk about Internet of Things, we refer to the massive quantity of things from different industry verticals connecting together, as well as kind of the personal health and monitoring and all these type of systems. But really, if we deep dive into this particular requirements of the variability of Internet of Things, what you'll find is basically there will be a few things. There will basically be the massive type of nodes connected to the infrastructure, connect to the network, that are basically like, today, you have your, basically the companies serving gas, electricity, these type of infrastructures, connect into the network where the data rate is very low, right? But you require very deep penetration, and yet you also require low cost. So this type of massive number of low cost, low data rate, but deep coverage type of devices you will need. And this will require a large capacity in network to support these massive Internet of Things. The other type that's very different is a type that's really you need a very critical latency to control and a high amount of accuracy. For example, as a drone become very popular, you need to be able to have mechanisms to control robotics and drones. And these will require much more precision. And what we call this is this is the type of IoE devices that require something called a mission critical type of control that has really high reliability, very low latency, and also strong security. So how to really be able to control both type of services into the network, massive amounts of them, and yet be able to accommodate them with a unified network that at the same time is still serving a high-speed mobile broadband, wider bandwidth. That's really challenging. That's really imposed in front of us. And that's really something that we're looking at solutions for 5G air interface to operate. So there are some things that we're looking at on what can we do to really address them. The thing to address them is, number one, we believe that from an air interface design perspective, just from the waveform, from protocol, it needs to be able to accommodate all of that. Okay, 5G air interface. So what this means is it can be a wider band, may still be OFDM based. We have to see how the industry plays out, how the different waveforms can be multiplexed very efficiently altogether. The second thing is what we call the multi-connectivity, meaning that in order to connect a massive amount of devices into the network, you will need all the spectrum and all the technologies that you can. Just like Peter has highlighted, you would have a device net, you have a service net. In the device, so basically what happens is no longer going to be the network infrastructure will no longer be perceived as you have a base station, you have a device that just connects to a base station with one hop. Things may actually go several hops, right? So basically a device needs to be connected to other devices in a D2D fashion, and your device may need any connection available, including the current 4G network, including using unlicensed bands and licensed bands altogether, including using Wi-Fi and the future 5G waveform altogether to be able to connect it. So the capability of the future devices may actually be a key in being relay also to some of the Internet of Things that's coming together. So that's the second aspect. And the third aspect is really a service platform, a core network platform. A platform where today we basically see that, for example, in LTE, you have a lot of the control planes residing in EPC, data plan coming from EPC, coming down to eNode B, the cell sites and coming down. Now, with the network being virtualized on the go, basically now you have the flexibility to move the control plane anywhere in the network, possibly closer to the edge, basically to allow you to achieve a trade-off that's between security and the convenience of access and how much it takes you to access to the network. So that's another aspect of the platform that we'll be looking at. Because of time limitation, we'll not dive into the details. But here I want to show you an example of an AI interface that basically can support a multiple set of network. What we have here is basically, if you remember, if you are familiar with the AI interface for LTE we have today, things are really more or less interlaced together. So you have one packet being sent, then you wait a little bit for an ACK to come, and the multiple interlaces work together. The reason we have that is because processing power was limited. You require a certain decoding time for a packet to be decoded, then basically to be ACKed and come back. However, as our processing technology is moving forward, this decoding latency can be shorter and shorter and shorter, in a sense that we can make every single TTI in the waveform to be something called a self-contained. You no longer need this kind of interlaced waveform. So by doing that, this kind of self-contained TTI frame structure allows the different types of interfaces to be multiplexed. You can have just a regular broadband interface here. Then you can have a D2D being punctured here. Then if you have IoE type of the waveform, you can have it happen here. But some of the waveform can be these mission critical, low latency, microseconds type of the services that really comes in. So this kind of mixture with a self-contained structure is something that we believe will be essential from an AI interface perspective to support all this massive number of Internet of Things. Okay, and so that's really something that we're looking forward. So of course we've been talking a lot about 5G, but we have to say that a lot of the understanding has been built from 4G onwards. So clearly the standardization for 5G will happen around completion, I think around 2018 timeframe, the first version. Then we'll move forward, and then 2020 is where we expect commercialization will happen. But one thing that's also very, very important, that's really for 5G in moving forward, is it also allows blank subframes there for future wave, because IoE is not a one-day thing. Every single thing requires different type of services. So rather have the AI interface being fixed in place, now you have the self-contained structure that allows the future waveform to be punctured in today's waveform. So the whole evolution can be forward compatible. So that way we make the entire IoE story to be sustainable for innovation for a longer term in the future. So that really comes down. So finally, I just want to say from Qualcomm perspective, we're fully committed to continue to work with academia and the industry altogether to really provide the best service and platforms to enable the high data rate growth, as well as to enable the massive amount of Internet things coming into the wireless infrastructure to work together. Okay, thank you very much. Yeah.
Sir David said this might be a mind-blowing experience, and Ming-Chi, you've just managed to do that. The scope of the vision is very exciting. So the next speaker is Sami Suziaho, who is the head of Edge Technologies at the Cloud in Sky, UK. And Sami, let me invite you to take the floor and maybe say a word or two about the role you play in your work, and then tell us what you're foreseeing now for this infrastructure. So thank you, and you have the floor.
Thank you very much. Good morning, everyone, and I'm very honored to be here today. Thank you very much. I stepped in for a dear friend, Steve Rathko from Ruckus Wireless, who unfortunately couldn't make it because of an unfortunate family incident. So let me tell you a little bit about myself. My name is Sami Susiaho. I'm a Finn, born and raised in Helsinki, where I did most of my professional career before moving to the UK 5 years ago. And I was in the fortunate position to be able to take a step back and think what to do next. The problem with Finland is, of course, market is very small, innovation is very high. So being able to do things like webmail that serves half of the email of the whole country before Google launched Gmail, and then of course seeing Gmail coming along and eating the lunch and shutting down the service, or building a Wi-Fi network to 50 cities in 50 of the biggest cities in Finland, and then figuring out that this adds no value whatsoever as a last mile connection replacement, and taking that down as well, and then doing it again, and eventually ending up in a place where I thought, okay, this doesn't make any sense. Let's go to a bigger market. London seems to be ripe for that. Lots of investment, lots of technology, a perfect place, and Wi-Fi seemed to be one of the key items that I had something to contribute. So I joined what I considered the leading Wi-Fi company in the UK called the Cloud Networks. One of the reasons was, of course, that it was a leading company, and the other one was that the VC money was about 3 years old, so it was ripe to be bought by a big company. Perfect time to join. And sure enough, Sky bought it a year later or so. And there within, I was faced with the challenge of connecting all these devices to enable the content to be provided to the end users. So Sky is a media company. Sky UK is all about that, how to put HD content to your tablet or your smartphone, wherever you might be. So as soon as you leave home, you're kind of stranded from a really good quality of network. And Wi-Fi network was the only way to provide gigabits and gigabits of data for users so that the users would still be happy. It would not give you a pleasure to watch Game of Thrones on your tablet if you paid for every megabyte as you download it from your 3G, 4G data packet. And therefore, that's the challenge that appeared at that time. But specifically to the Internet of Things. Of course, our customers want to connect machines to the network. So if you go to a restaurant, they want to connect the fridge temperature sensors as well as the TV monitors that show advertisements, or they want to connect the users at the same time. And this is incredibly difficult to do. Through my professional life, I've always looked at the latest technology and then beat it down to the dumbest possible form so that we can actually deploy it. And that's incredibly difficult. I mean, it's almost like building one of these model ships, really nice, with sails and all of that, and then someone saying that, okay, now you have to give it to your 3-year-old so he can build it, and you have to put it into this bottle. So that is almost I think it's a very good analogy on what happens when a very good slide set about what 5G will be, and how do you actually deploy it in the real world? It has to be dumbed down quite a bit, and then made usable for all kinds of devices. So specifically on Internet of Things, the fridge temperature sensor is my Achilles heel, because these things have very low power, very low quality, if you will, on the radio interface, and they have to work in the same network as the smartphones. So you can either configure the network to be massively fast and video streaming and all that, or you can connect tons and tons of devices. It's hard to do both, though. In order to enable the devices to connect with bad connections is one of the things that you have to do, and that's specifically what we're trying to avoid when serving the smartphones. So we built this technology called admission control, which is coming to... It is one of the most important things when 5G is coming along. In order to not to hijack the Wi-Fi interface of the device, you have to have some guarantee of service before you associate the device. And to be able to do that, you can't really give the device that decision point, because the device has no idea what the network will be unless it connects and does some tests, which takes time, which kills seamless roaming. So you can't do that. So the network has to know whether or not the quality of the network would be there if the device connects, and therefore not connect the device unless there's some quality of service guaranteed. Now, with the fridge temperature sensor doesn't care about the quality. It just wants to get connected and move very small amounts of bits and bytes And it doesn't care about latency, it doesn't care about quality. As long as it gets the couple of bytes out within the hour, that will be fine. And the smartphone, of course, doesn't really operate on the same kind of parameters. So now you have to start to identify if the device is a smartphone or temperature sensor that doesn't move at all. And that is extremely hard to do in the real world. You could always take some data, pull it to a database, mine it, make an opinion, and feed it back to the network. But this takes, minutes, 15 minutes or so, and you don't have that. The smartphone won't wait for 15 minutes for the decision of whether or not to be connected. It will wait some seconds. So the intelligence has to be on the edge of the network, where within is the challenge. Now, we have very successful pilots running this kind of technology. Unfortunately, we couldn't get it to the standards on Wi-Fi Alliance, for example. We were considering to put it on the Hotspot 2.0 or Passpoint Phase 3, but instead of that, we decided to do something else. So unfortunately, I had to make a proprietary way of doing it, which I always hate. One of my jobs is to sit in these alliances like Wireless Broadband Alliance or Wi-Fi Alliance or all kinds of work groups nationally as well, where we look into new technologies and what's going to be on the field in the next 2, 3, 5 years maybe, and then try to drive the technology towards what is useful, what the field would actually like to see. And I'm almost unique in that perspective where I can see the standard being written and I can see the network being operated. And it's incredibly useful to be in that position when considering the use cases and the challenges of the real world. And for the Internet of Things, the quality of the network isn't as important as the smartphones, if you will. So that's kind of one of the big revelations. Steve Ratko asked me to mention one thing, though, from his perspective, which was spectrum crunch. In the UK, I'm not sure how many of you are from here, but specifically on the license-free space, 2.4 gigahertz and 5 gigahertz spectrum, we are, of course, spectrum constrained already. We have a Wi-Fi network outside in the city of London, and it's borderline not fit for purpose because the congestion on both of the 2.4 and 5 gigahertz bands. But that thing aside, 2.4, for example, is at the moment being crunched from below and above. Above is the satellite provider who remains unnamed, who wants to extend their reach and tries to grab channels 12 and 13 on the top end. And at the bottom end, UK wants to launch LTE on 2.3, 2.390 actually, being the top end of the band, 10 megahertz from the unlicensed band, with power levels that much exceed what Wi-Fi is allowed to use, or any license-free for that matter. And the regulator's suggestion to mitigate this problem would be to go to 5 gigahertz, which of course you can't do if you're a temperature sensor in the fridge. You can't change the device either because there's millions and millions of these deployed. But the regulator decided to not worry about it that much and leave the industry to worry about it. So it is my distinctive pleasure to address the problem of the Internet of Things, of deciding on whether or not we can operate on the 2.4 gigahertz ISM band with our sensors in the next few years when the 2.3 gigahertz LTE starts to roll out. We don't know yet what the deployment will look like, so we don't actually know what the impact will be. However, we do know there will be an impact. And 5 gigahertz is almost the same. We have LTE coming on it, not as an LTE-U, but at least LTE LAA with coexisting mechanism, which is yet to be defined. So again, that's an interesting space. So it's an extremely exciting place to be in the timeline of technologies where we have massive usage on the spectrum, millions of devices coming, an order of magnitude of growth all of the time. No one bats an eyelid when someone shows a hockey stick slide over there showing growth. It's just kind of what we used to hear now, but technologically it's a very big challenge when you have an order of magnitude of devices coming along and order of magnitude of usage increase, and you still have the same amount of spectrum, and fundamentally there are no big advances in technology in terms of backhaul speed or bits per hertz and wireless. So that is pretty much my day job, 10% of it. And I think that is enough of an introduction from my point of view at this moment. I think we have a panel where we can address these things into a more detail. Thank you.
Now for something completely different. It's important to hear from the European Commission view, and Thibaut Kleiner is going to help us see what he sees from the Commission point of view. He's head of 5G and Internet of Things. I don't know whether you call it the division or the department or something. So, Thibaut, would you like to come up and give us a sense for what is mostly concerning to you about the leading edge of the Internet of Things and how you're looking at it from the regulatory point of view? So, Thibaut, welcome. You have the floor. And you might give them a better sense than I did of what your responsibilities are.
Okay. Thanks, Vint, and good morning, everyone. So very honored to be here with you, and I think Peter really assembled a very interesting and intriguing program. So, as far as I'm concerned, I'm heading the network technologies in the European Commission. So what we do is that we support innovation and research through funding, but we also develop policies to make sure that there is take-up of these technologies across Europe and more generally